G'day guys, I've had a request to do this trigonometry question. The student's doing a little bit of revision and they've run into a spot of bother with it. So what we've been asked is we've been asked to prove that y is equal to 4 sine of theta, which is this angle here, over sine of phi, which is this angle here. So basically, I've just had a look at this problem and we're going to be using a little bit of Pythagoras and a little bit of the sine rule, as well as a knowledge of our exact values in trigonometry to basically prove this. So what we're going to do is we're going to work our way around. Well, I think the best way to do it is to work our way around. We will figure out what this side is equal to. We'll call it A. Then we'll work out what this side here is equal to. We'll call that B. And then we'll be able to solve for y, or prove that y is equal to this, whatever you want to call it. Okay. So let's figure out how we're going to work out A. Now, we've got a right angle triangle here. We've got two values here and no angles, so naturally Pythagoras comes to mind. So what we're going to do is hopefully you guys are aware of how Pythagoras works, so we have A squared is going to be equal to 4 squared plus 2 square root 2 squared. Now, that's going to be equal to 4 squared is 16. Now, 2 root 2 squared is 2 squared, which is 4, times square root 2 squared, which is 2. So, 16 plus 8, which is equal to 24. So we can then say that therefore A is going to be equal to the square root of 24. Now, in any problem like this involving trigonometry, it's always good to then simplify your surd. Now 24 is like the square numbers that go into that is 4. So it's 6 times 4. So we're going to have the square root of 6 times the square root of 4, which is 2 times the square root of 6. Cool. Now if you guys are having trouble with simplifying your surds, I've got other videos on that which you can find on my channel, but we're just going to keep rolling on. So now that we have A, we've got to try and figure out B. So naturally, we have a look at what the triangle we've been given. Now we've got one side now because we've worked it out, and we have basically two angles. So what we're going to have to use here to find B, because we've got the opposite angles to each of our sides in question, we're going to be able to use the sine rule. Now, let's just do a quick refresher on the sine rule that states that A over the sine of A is equal to B over the sine of B. So that's our sine rule there, equals C over the sine of C, and so forth and so forth. But we only have A and B, so this is all we're going to use. Okay. So we'll just separate this for a second, and we'll go straight into this. So we have A, which is equal to 2 root 6. Divided by the sine of A, which is 60. So divided by the sine of 60 degrees is equal to B divided by the sine of B, which is equal to theta in terms of its degrees. Alright, now this is where our knowledge of exact values comes in. So we'll go back up here, and we know that the sine of 60 degrees is equal to square root 3 over 2. Now these exact values, or the exact value table, is very, very important to commit to memory. You should learn this by rote. There shouldn't, some teachers will teach triangles and other kind of poems, I don't know what haikus, whatever you guys learn to remember the exact values. But look, the long and the short of it is you've got to learn these by rote. There's only a couple that you have to remember, so I would just sit down one day and commit them to memory. Because if you're studying any kind of finishing school, year 11, year 12, AP, geometry, anything that involves trigonometry, you're going to have to know these in an exam situation. So just learn them, suck it up, I guess. So, going back to where we were, 2 root 6 over the sine of 60 is like saying 2 root 6 over square root 3 over 2, which is also equivalent to 2 square root 6 multiplied by 2 divided by the square root of 3. And that's equal to b divided by the sine of theta. Cool. Now, what we can do here is we're going to simplify this part of our equality. So, going back up to our little writing in red, 2 square root 6 is equal to 2. Now 6 is 2 times 3. So 2 times the square root of 2 times the square root of 3. Now the reason that this is important that we do this is because then we can, if we come up here, we can go 2 root 6, which is equal to 2 times the square root of 2 times the square root of 3 times 2 over the square root of 3. You can see, sorry, that 2 is shocking, 2 over the square root of 3, you can see that these square roots of 3's will cancel out. And we're left with 2 root 2 times 2, which is equal to 4 times the square root of 2. Now, so that's that side of the equality done. Now let's just make that equal to the other side. So that's equal to b divided by the sine of theta. Cool. Now, we can then, it's quite simple to say that b is going to be equal to 4 square root 2 sine theta. Cool. Now, we've solved for b. Now we have to relate b and y. Now you can see that the situation that we have here is exactly the same as the situation that we had in this second triangle. We have two sides, one of them is unknown, and we have two angles, so we're going to use the sine rule again because we have sides and they're at opposite angles. So let's go about it. I'm going to change color just so we can see what we are doing. Will we be able to see this color? Let's just check. So what we can do is we can say y divided by the sine of 45 is equal to b divided by the sine of phi. Now this, y over the sine of 45, well, we know that the sine of 45, you should know that the sine of 45 is equal to 1 over the square root of 2, or root 2 over 2. But these are equivalent. I'm just going to use 1 over square root 2. So if we're dividing both sides by 1 over square root 2, that's the same as multiplying this side by square root 2 over 1. So that's what I'm going to do. This is equal to y times the square root of 2 over 1 is equal to b, which is 4 square root 2 sine theta over the sine of this new one, sine phi. Now, it's quite simple to see that what we're going to do is we're going to divide both sides by the square root of 2, and we have y equals 4 square root 2 sine theta divided by the square root of 2 sine phi. Now we can get our big red pen. The square root 2's will then cancel, And we're left with, now I'll put this back into blue, y equals 4 sine theta divided by sine phi, which is our answer. Cool. So let's just check out what I've worked through the problem, but let's just check out the sort of the tools that you guys will have to be able to work with to be able to solve a problem like that. So you might not believe it, but a lot of kids in an exam, sort of a pressure cooker exam situation, will look at this question and go, oh wow, this is a complicated trigonometry question. I don't have to use trigonometry or triangle-based methods that I learned when I was 12 or 13 years old, like Pythagoras. So many students that, like in my experience, will miss this first step to get A. They'll just be bamboozled by the whole problem, and they won't get the fact that they can just use a method that they learnt when they were 13 to solve this first part. Now, once you've got the first part using Pythagoras, you must be aware that you can use the sine rule here. Like, you have to have done enough sine and cosine variations of questions to be able to understand when to use the sine rule and when to use the cosine rule. Now, these are both non-right angle triangles, so the sine rule and the cosine rule is basically all that you've got to work with. So making the choice, and you have to do it quick, because a question like this in an exam won't be worth as many marks as you think. So a knowledge of the sine and cosine rule is very important, and then also to make sure that you can do this problem quickly without having to draw triangles or go through haikus, you must be aware of your exact values. And then on top of that, the icing on the cake, which you should know if you're doing problems like this already, is how to simplify surds. So first of all, making sure that you don't discount that you can use Pythagoras in trigonometric problems when in your later years of high school. Second thing is a good working knowledge of the sine and cosine rule, which just comes from practice, guys. So you know you can look at a problem and know when to use it. Thirdly, a very, very good understanding of what all the exact values are of sine, cosine, and tan of 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So you can work all of these sine, cosine, 45s, and 60s out instantaneously. They should be committed like your multiplication tables. And then finally, you have to know how to simplify surds. But I'm assuming that you should already know how to do this if you're trying to attempt problems like this. But until next time, guys, this isn't a too hard a problem if you break it down into steps. But when you're confronted with all of the steps in one hit without any sort of coaxing, it becomes quite a complicated problem. But, you know, a little bit of practice and I'm sure anyone can get it. So I hope the video helped, guys. If it did, give it a thumbs up. Subscribe to my channel. I put out new videos all the time. But until I see you again, or you see me again, sorry, have a good one and enjoy your trigonometry.